All right, wonderful people, let's get started. By the end of this, you will be able to add and subtract complex numbers, multiply and divide complex numbers, classify complex numbers and their properties. All right, so what is a complex number? So let's look at something like this. 5 plus 2 times the imaginary number, or 2i. 5 is a real number, and 2i is an imaginary number, or what we would call a pure imaginary number. We covered that on a previous lesson. They are not like terms. We can't put them together, right? We cannot combine them. It's just like if I were to have any other variable other than I, like if I were to have 5 plus 2a, we would not be able to put them together. So we don't put them together as is now. So this is what we call a complex number. And this is the standard form of a complex number. There is a real part, because like, again, 5 is a real number, just like a would be a real number. But this one having the I would be an imaginary part. All right, and moving on, let's go ahead and look at adding and subtracting complex numbers. So to simplify it, we must put the answer in a plus bi form. All right, now this is kind of easy. Let's go ahead and combine the actual numbers together, the real number. So negative 11 and 9, put them together, you get negative 2. Three I and 2i, put those together, you get 5i. And actually, I think that might be the final answer. Not much else we can do with this. So go ahead and box it up. That's our answer. All right, now let's go ahead and put these together. So 4 and 7, this would be 11. And combine these. And again, it's just like any other variable. If this was a minus 5a, you know, nobody would think twice about that. They would like pretty much know what to do. So that would be negative 4i. Okay, now that was, again, pretty easy, and we're done with that one as is. Nothing else for us to do here. All right, more of the same. Now in this case here, we are subtracting these numbers here. So in subtracting, we have one small thing that we got to watch out for here, and that is we got to make sure that we know we are subtracting all the numbers or all the terms in this second group. So this 2, that's being subtracted. This 6i is also being subtracted. So it's just like distributing, because you can think of this as negative 1 here, like that. Now let's go ahead and combine our like terms. So 7 minus 2 is going to be 5. And let's see, combine negative 2 and negative 6 together, because they're both the I term. So that would be negative 8i. And it looks like we're done with that one. Moving right along. All right, now again, we have another instance where we are subtracting a group. So when you subtract a group, you got to remember to subtract all of the pieces, all of the terms in that group. So in this case here, that would be reversing the sign of the 14 and the negative I, so that they are now opposite sign. And if it's a plus, you don't need to change the sign. The sign pretty much just stays the same. So if you're adding, like in this case, we're adding a negative number, that's just the same as subtracting a number. All right, now we got to add our like terms together. So 6i plus I is 7I. 7I minus 3, or actually in this case, well, okay, I'm going to stick with the way we should do it. Let's do the real number first. Even though my first term is I really should do the real numbers first. So this first one here would be -9 plus, and let's get back to that I. So 7 minus 3 would be 4I. All right, looking pretty good. All right, so for this one here, we need to remember from the previous lesson that I square is equal to -1. All right, so that would be this page here. Remember, we worked out a couple of these things, and differing powers of I have different equivalent values. So we might need to refer to this chart in later lessons. All right, so multiplying them out. So we got to multiply using distributive property, 2I times 8. So let's see, that'd be 16I minus, let's see, 2 times 3 would be 6. I times I is I square. Now, if we run into an I square, we need to substitute that in with -1. So 16I minus 6 times -1. All right, and multiply this, so we get negative times negative, and it's times 1, so the value is not going to change. So that's going to take it into a positive 6 plus 16I just like that. And I just switched the place here so that the I is the second number, and that is, again, we want to make it into that standard form. Well, not really, I don't know if it's a standard form, but yeah, it is standard form, sorry. Standard form of a complex number is what it is. So standard means like you do the same thing every time, right? That's what standard means. It's the same thing. All right, looks like we're going to have to multiply -I times both of these. Again, distribute. So this would be 2I plus 10I square. All right, nothing we can do with this 2I, so let's leave that. 10 and I square is going to be replaced with -1. So that's going to make it, this is going to be our real number here. Oh, wait a minute. You know, I almost missed something here. This is supposed to be a negative, because remember, if you multiply by a negative, you got to change the sign of the second one, because wherever this negative goes, you know, it's gonna have to multiply to this one as well. Anyway, back to here, negative times a negative will be positive, so positive 10, and I'm going to just switch the place. And this is a positive 2I, so plus 2I. Looks like we're done with that one. Moving right along. All right, now, let's see. Looks like we have to use our FOIL method. So FOIL, remember, just a quick recap, first numbers, outside numbers, inside numbers, last numbers. So we're gonna end up with 4 terms, and we're gonna have to end up replacing some of these. So let's go ahead and do our first 2 numbers in each group here. So 7 times 4 is 28. 7 times -I is -7I. Don't forget those signs. Inside here, so the inside numbers, the 2 closest numbers, 4 and I, put them together, you get 4I. And let's see, I times negative I would be negative I square. And again, I square equals negative 1. So let's combine as much of our terms as we can. So in this case here, I get negative 7 plus 4, so that would be negative 3i. And let's see, replace this with negative 1, so I get opposite of negative 1, because this part becomes negative 1, but there's already a negative there, so we got to not lose our negative, not just take out or put in negatives. We've got to keep track of those negatives. And that's going to be 28 minus 3i plus 1. So just add 1 to 28, and we get 29 minus 3i, just like that. And it looks like we are done with that one. Moving on to number 8. Using our FOIL first number, so 2 times negative 5, it's going to make a negative 10. Outside numbers, and again, watch out for these signs, so that's going to be negative 6i. Inside here, I have negative 4 times negative 5, so that's going to be plus 20i. And let's see, what am I going to have for this last one here? Negative times negative, my last two numbers, that's going to be a positive. 4 times 3 is 12. I times I is I square. And let's go ahead and combine what we can. So negative 10. And let's see, here we have plus 14i plus 12 times negative 1. Now there's kind of a shortcut here. If you notice that anytime you have an I square, it's just going to reverse the value of that last number. So here I have positive 12, and it's going to make it into negative 12. So negative 10 plus 14i minus 12. Combine our two real numbers together, so I get negative 22. Go ahead and redo that. 22 plus 14i. All right, so if your multiplication skills with FOIL are pretty good, this is not going to be a very difficult lesson. All right, moving on. Just going to save that. All right, looks like we have another set of groups with this one here. Now, when you see a square on a group, that means you have two of those entire groups. So I'm going to go ahead and expand it out. You may not need to do this, but I would recommend it because writing it out allows you to see all of the terms, you know, and not miss anything. So let me go ahead and rewrite that I. There we go. It's a little bit better. First number, 6 times 6 is 36. 6 times negative 2 would be negative 12i. Inside number, it looks like we're going to get negative 2i times 6 again, so another negative 12i. And here, last number, so negative times a negative will be positive. 2 times 2 is 4. I times I is I square. All right, let's start combining our terms now that we have no more multiplication. 36 minus 24i plus 4 times I square, which I square is negative 1. And that basically means we're going to minus 4. So 36 minus 4 is 32. minus 24i. There we go. We combined all of our like terms. Not much else to look out for. Okay, looks fine to me. Moving on to the next one. Okay, let's FOIL this out. So 1 times 9 is 9. Outside number 1 times 3i is going to be just 3i. Inside number here is going to be 7 times 9, which is 63. I. And last numbers here, we have 7 times 3, which is 21i square. Because I times I is going to be I square. And here, let's go ahead and distribute the negative to both of these terms. So negative 4. And make sure we change this one to a negative. Okay, be careful because that is easy to forget. So that'd be negative 2i because we are subtracting all of the terms in this group. Okay, so let's go ahead and start combining numbers that we have. So I'm going to look for my real numbers. So 1 and 2. And this one is going to change into a real number, but I'm going to try to avoid skipping steps whenever I can. So this is going to be 5. Or hold on, 9 minus 4. All right. You know what? Let me see. Underline this, and this as well, because I'm gonna kind of color code these. And just because I'm afraid of making a mistake, I'm gonna be a little bit careful about this. So 9 minus 4. And let's see, this 21i square, so 21i square, so it becomes 21 times negative 1, which is going to be negative 21, I believe. So minus 21. All right, and there you go. That takes care of all of our regular numbers. Let's go ahead and put our imaginary numbers in. So 3i plus 63i minus 2i. All right. Whew. I want to make sure I didn't miss anything. So 9 minus 4 is 5. And, or actually in this case, it would probably be easier to combine my two negative numbers first. So this would be negative 25. 9 minus 25 would be negative 16. 3i minus 2i, so 3i minus 2i, well, let's see. Actually, you know what, let me put these two together here. So we get 66i. 66 minus 2 is 64i. All right, there we go. That one had quite a lot of steps in it, but we shouldn't let that intimidate us. We just got to keep working one step at a time. Okay, let's see, moving on. All right, so here we have complex conjugates. So if you have two complex numbers in the form of a plus bi and a minus bi, we call those complex conjugates. The product of two conjugates is always a real number. So again, they look the same, 8 and I, but one is joined with a plus and the other has a negative. Same thing here. 5 and 4i, 5 and 4i, different operation. So 8 times 8 is 64. Outside number is negative 8i. Inside terms is also going to be plus 8i. And last numbers here. So this would be negative I square. All right, so let's go ahead and get 64. Now, in this case here, this would be 0i because 8 minus 8 is going to be 0. So it's gone pretty much. And negative I square is going to be negative 1. Well, hold on. So the negative is still there, right? But this negative here is there, but when I replace it, it should be negative 1. So I end up with basically a double negative. So that would be 64 plus 1, and that would be 65. I don't need to write 0i because anything times 0 is going to be 0, which is nothing, so I'm not going to write that down. So in this case here, we get a real number of 65. It's a real number. There's no more imaginary parts. So this is not a complex number. This is a real number. All right, let's go ahead and do this one now. So 5 times 5 is 25. 5 times 4 is 20i. And inside terms, here's the two closest ones. This is going to be 4 times 5, but it's going to be negative 20 because of the negative 4. And here we're going to have it cancel out. 20 minus 20 is going to be 0. So for this one, I'm going to just skip that step of writing it in the next one. Here I'm going to have, let's see, negative, negative, because negative times positive. 4 times 4 is 16, and I times I is I square. So 25 minus 16 times negative 1. And again, I'm just going to ignore this part because it already zeroed out. They cancel out completely. And this is going to be 25 plus 16. So 25 plus 16 is 41. And that's it for that one. All right, dividing complex numbers. So be careful because I cannot be in the denominator of a complex number. So in other words, you cannot have I as the bottom number. In fractions, the bottom number is kind of a touchy subject. Bottom number cannot have roots, it cannot have I, and there are a few other things that it cannot have. But in this case here again, we cannot have I in there. So if the denominator is a monomial, multiply the bottom and top by I. Now, just a quick refresher, if I wanted to add, say, 5/6 to 7/12, just standard fractions, one thing you can do is double both of one number. Because when you're adding fractions, you want that bottom number to be the same. So 10/12 is the same as 5/6. It's literally the same thing. All right, don't get fooled by that. Let me go ahead and grab a calculator just to prove it to you, because I always get students that are always confused saying things like, oh, fractions are so hard. Okay, fractions are not hard. You just need to know a couple of things. 5/6, we got 0.83333. And if I were to do 10 divided by 12, I get the exact same thing. They are the exact same value, no different. So you can get equivalent fractions. That means two fractions that mean the same thing, even though they look different. So what we're going to do is we're going to multiply our top number by I and our bottom number by I. Let me write this a little bit better. Let's see. And I'm probably going to get a question of, why does this work? Well, if you remember, in fractions, any number divided by itself is equal to 1. So I over I is equivalent to just saying 1. any number over itself is always going to be equal to 1. So timesing something by 1 does not change its value. That is the multiplicative identity property. Multiplying something by 1 does not change it. So 10i over 2i squared. And that's going to reverse the sign on the bottom number. So that's going to be -2. So I got 10i over -2, which is going to, I'm going to divide the fraction, divide the number. So 10 divided by 2 is 5, and negative. So remember, if you divide a positive by a negative, it's going to come out to be negative. And I, being my top number, just comes down like this. So I'm able to simplify it to -5i. And we're done with that one. Moving on, it looks like I'm going to have to do the same thing to this side here. So times it by I over I, or multiply top and bottom number by I. And that's going to give us 4i over -9i squared. And again, I'm going to replace I squared with -1, just so that way, well, I can reverse that. So, all right, 4i over, and this is going to be 9 negative and negative, so that's going to be +9. And that's it for that. That's about as far as we can go. All right, it's going to stay a fraction. I cannot divide 4 by 9 and get a good number in there. And you might be thinking, well, can't I just divide it with a calculator and get a decimal? Well, yeah, that kind of works out, but we might as well just leave it as a fraction in this case, because we would get something like, well, we'd get something, but this is better, I think. All right, we're going to have to do the same thing again. Now, on this top part here, we have a group. If you remember my discussion with the order of operations, or PEMDAS, I say PEMDAS doesn't quite work out. We need not parentheses, but grouping symbols. When you have a group, we're going to put a parenthesis around it. And anytime you have a fraction is a grouping symbol. So 28i minus 8i squared. So we got to multiply both of those out. Again, using distributive property. Okay, and I'm going to go ahead and I don't think I can really do much with this here, I don't think. But I can switch this out. 28i minus 8i squared. And I'm going to go ahead and just sort of skip a step, because I know that I squared is -1, so that's going to be -4. Now I'm going to try my best to divide both of these by -4, which it looks like it might work out. Okay, I should have also reversed these as well, reverse the placement, just to save myself a little bit of space, because it looks like I'm running out. So I'm going to do this one here. So this would also be replaceable with -1, which is going to become my new real number. So negative times negative is positive, so that would be +8 divided by -4. +8 divided by -4 is going to be -2. Here I have +28 divided by -4, so that's going to be -7i. Okay, all right. There are a couple of things I could have done that I could have done there to make it a little bit smoother. Okay, well, let's go ahead and just get to this next one now. So same thing, times I over I. And I'm going to have to put a group here. So negative I, 8I here. So multiply that by I. Here we have negative 2I square. And now we know that this negative 2I square may become a real number. So I'm going to switch the place in a second. But let me go ahead and finish this out here. So there you go. So I'm going to switch this place. Now again, I squared becomes negative 1. So negative 1 is going to reverse the sign of this. So we get 2. And the I square is gone. Minus 8I over 6 times negative 1. But again, I'm going to replace that with negative 6. And now this should be a, well, it looks like we cannot divide this actually. We can't really divide it at all. So we are going to have to, oopsie. What is going on here? We're going to just reduce it. So they're all even numbers. So I'm going to just divide everything by 2. So divide that by 2. Divide this by 2. And divide this by 2. And it looks like we cannot do anything else from here. So let's go ahead and call this the answer. Yeah, oh well. All right, so looks like we have a couple more things to do. Same thing, cannot have I in the denominator, so we're gonna have to multiply it by I over I. And again, you can multiply any fraction by the same number on top of that same number, and it doesn't actually change the meaning. So I know people are gonna be like, well, you're multiplying and doing all this stuff. No, it is not any different. It is still the same number. All right, so let's see what we get here. Negative 2I over, and multiply this as a group. Let me put a parenthesis here to make it a little bit easier to see. 5I minus I square. And I'm going to go ahead and replace I square with negative 1. You know, I don't think this is going to work out actually, because this I is still there. So we're going to have to do something a little bit different with this one here. Yeah, that I would not have disappeared, so we're going to have to do something a little bit different. So what can we do? Well, if you remember a while back, we were talking about complex conjugates. Not sure exactly which slide that was. But we're going to do something like that with this one here. So we're going to have to try to make it into a real number. So that's going to be 5 plus I. So I'm going to multiply both of them by the group of 5 plus I. And this still works out because, well, it's the same number over the same number, so it's still going to be equivalent to 1. But this is going to be a little bit more work. Negative 10 minus 2I, because that's distributive. But this bottom is going to be a little bit tougher on the bottom. So 5 times 5 is 25. Plus 5I minus 5i minus I square. Ooh, might need this to be a little bit longer here. Okay. Let's see what I can do about this bottom number here, negative 10 minus 2i. Now this is going to be negative 1. And it looks like these are going to cancel each other out. So 5i minus 5i, that's going to be 0. So there's not going to be anything left there. So this would be negative I square is going to become plus 1. Right? Don't forget that. Let me just write that out. Minus, because the minus sign is still there. And I replace I square with negative 1. There we go. And let's see, negative 10 minus 2i on the top. We're not doing anything with that top number just yet. Let's see what we get as our bottom number. So 25 plus 1 is 26. And I run into a situation where I cannot divide the top number by the bottom number. So just like with fractions, if you can't divide it, all right, if you can't divide a fraction, reduce it. So they're all even numbers, so I'm going to reduce all of them, or divide all of them by 2. There we go. That is reduced to lowest terms, and we are done with that one. All right, it looks like we're going to have to do something similar to this one as well. So we need the conjugate. We need the same thing, but opposite sign. Because we got to get this I all the way out of there. No i's in the bottom number. All right, so I'm going to go ahead and maybe work a little bit over here. So that would be 30i. Okay, that looks about right. Minus 10i, because we're multiplying 5 times 2, so that's going to be 10, but there's a negative in there, so that's going to make it negative. And I times I is I square. Oh, come on, straight lines. Where are you at today? There we go. Well, close enough. All right, and FOIL, we're gonna have to FOIL this out. So 36, outside number is negative, let's see, it's 12. I think it's negative 12i. Inside is gonna be 2i times 6, which is plus 12i, which is gonna cancel out. Plus, well, in this case, it'd be negative because, well, one of them is negative, and positive times negative is going to be a negative result. 2 times 2 is 4, and I square. Okay. Now let's try our best to simplify this. 30i minus 10i, and I get 36 minus 4 times negative 1, because don't forget negative 1 is the equivalent of I square, and these cancel each other out. The two middle terms of 12i, yeah, 12i minus 12i, that's going to be nothing left. So I get 36 plus 4. So I'm going to get, let me go ahead and write the next step. So 30i minus 10i. (36) plus 4 is 40. All right, now we notice they're all even, and we can't divide all of the top numbers by the bottom numbers. So we're going to have to reduce it. So even though they're all even numbers, you might be thinking, well, can't we divide all of them by 2? which maybe we can, but that's not the greatest common factor. The biggest number I can divide out of all of those would be 10. So that's what I'm going to do. I'm going to divide everything by 10. Oh, wait a minute. Oh, this is supposed to be I square. So you know what that means? That means I am going to have to switch this to a plus. I know it looked kind of funny with two I's on the top, but that would just, again, become -1, and that would be -1 times -10, which would be +10. All right, almost missed that. Almost missed that. Oh, and that would still be positive here. And that looks like our answer for there. Okay, moving on from that one. Oh boy, looks like we got more. Getting rid of these bottom numbers, getting I out of that bottom number. I just cannot seem to get straight lines today. All right, much better. And we got to multiply it. Now we got to look at the bottom one. That's the one we're trying to get the I out of. So 2 minus I. And that means I'm going to have to multiply the top also by 2 minus I. And again, these would have parentheses on them. They are grouped, okay? A fraction is a grouping symbol. Anything on top or bottom of a fraction is grouped together. All right, so multiply it out. 14 minus 7I, 6I, multiply the inside. Now the last number is going to be -3I squared. Gotta be careful with that square sometimes. Easy to forget it. All right, 2 times 2 is 4 minus 2I plus 2I. I times I square is -I square. All right, now, just for simplicity's sake, I'm going to go ahead and eliminate these and replace it with -1 right now, because this is going to take a little bit of writing. And it helps it it just helps it go by a little bit faster. So, okay, let's see. 14, and this is going to become a positive, so it's going to be +3. So that's going to be 17. So I'm adding this number to this number here. And let's see, -7 plus 6I, it's going to be -I. All right, now these two are going to cancel out because they're both opposite terms. And 4 plus 1 is 5. All right, I skipped a few steps there, but hopefully I didn't lose you. Okay, because again, this is just going to be +1. And it looks like we're done. I think that is lowest terms. It doesn't look like there's anything we can reduce everything by, so that's done. And again, we have no I in the bottom number, so that's what we want. Let's do this one now. So looking at the bottom number, we need the conjugate to that one, which means we need the opposite sign. And whatever we do to the bottom number, we have to do that exact same thing to the top number. use our FOIL method. So let's see, 1 times 2 is 2. And that would be plus 4i plus 8 times 2 would be 16i. 8 times 4 is 32i squared. All right, there you go. It looks like we got our top numbers taken care of. Let's do our bottom numbers now. 2 times 2 is 4 plus 8i, my outside numbers. Inside number is going to be negative 8i, because again, negative 4 and positive 2, and there's an I there, so let's go ahead and get to the last one. Negative 4 times 4 is 16, and I square. And again, just to keep things moving a little bit faster, I'm going to go ahead and replace I square with negative 1. And if you want to write out an entirely new work, line of work, showing your work to show how this negative, this would be negative 32 and this would be plus 16. All right, that works out fine. But let's go ahead and start simplifying this as much as we can. Maybe we could get it down because we might have to do a little bit more simplification. All right, let's go ahead and start with our real number. So this is 2 minus 32. So 2 minus 32, and that's going to be negative 30. Combine our imaginary numbers together, so that would be plus 20i. And let's get our bottom number. So again, this cancels because it's going to be 0i. But again, that's kind of what we want. We want to get rid of all the I in the bottom number. And that's going to be 4 plus 16. 4 plus 16, because I'm just doing this in my head where negative times a negative is a positive, so that would be plus 16. And again, we run into all three numbers that look like they are divisible by 10. So that's what I'm going to do. I'm going to divide all of the terms. Now, when you do this, it has to be all three numbers, not just 2 or anything like that. All three of them have to be divisible by the same number, which in this case, again, is 10. So divide by 10. Divide by 10. And lastly, divide by 10. Doesn't look like we can do anything else, and I is gone from the bottom number. So we are done with this one. Okay, looks like we're gonna have to go into a little bit of something else here. So a little bit of something different. All right, so we've already covered real number and real number properties. So things like natural number, whole number, integer, rational, those should all be familiar to you. Everything right up until about this box. The new stuff is what's on the outside of the real numbers. So imaginary numbers, as you might guess, are not real numbers. But complex numbers, now remember, complex numbers have a real part and an imaginary part, but that imaginary part takes them out so they're no longer real numbers. So that's why the complex and pure imaginary are outside of real numbers. Other than that, everything else is still the same. And remember, if one circle is inside of another circle, then that means that it belongs to that group as well. So for instance, a natural number is a whole number, a natural number is an integer, and a natural number is rational and a real number. But let's go ahead and look at integer just as an example. An integer is rational and it is real, but it is not necessarily a whole number. It can be. An integer would be like 5, which 5 is whole and natural, but integer could also be something like -5, which -5 is not whole and it is not natural. But it is, -5 is rational and -5 is real. So remember, if something is grouped inside of a circle, it also belongs to that group. All right, now let's go ahead and classify some of these. So here I have -64, which you might remember how to do this. We may break it down into two numbers that we can reduce. So in this case here, I would have -1, which is I, right? Because we're taking out -1, the square root of I. Remember, let me just refresh you on that. I is equal to the square root of -1. And we're going to take the root of 64, which is going to be 8. So I want to put this in the coefficient because I is like a variable. And there we go. So we simplified it, but we got to also classify it because it says name all the sets to which it belongs. So this is a pure imaginary number, so it belongs to I group, right? It belongs to this group right here. Now it does not have a real part, so it is not complex. Or is it complex? Oopsie. So looking at the chart, it looks like imaginary numbers are also complex numbers. So if it's a pure imaginary number, it is also a complex number because you could rewrite this as 8i plus 0. So it would also be a complex number, judging by the diagram. So there we go. All right, it looks like we're going to have to do a little bit of work on this one here. (10 times -2, so that's going to be, let's see, -20, and we have I times I, which is I square. And I square, let's see, -20 times -1, and that's going to be just plain old 20. Oh, I should probably use a semicolon here to show that this answer set is going to be different from this answer set. And 20 is pretty much all of the numbers. It is natural, it is whole, it is an integer, it is rational, which is Q. So Q is rational, which is kind of weird. But R is real number. Well, capital R. And C. So that one is pretty much everything. Okay, working on this next one here. I got the square root of both of these. So square root the top, square root the bottom. Square root of 1, remember 1 is a square root. Square root of 1 is 1 because 1 times 1 makes 1. And oh, where am I? I'm getting ahead of myself here. I put in 3 there. I know what it's going to be. I know it's going to be 9. I already had 3 on my mind. So square root of 9 is 3. Sorry about that. And 1/3. So we have a fraction. So a fraction. So 1/3 is the value. Semicolon because we're going to split it. So that's a rational number. It is a real number. And a complex number because it has, it's complex because it has, well, it has no imaginary element. But in this case here, if we're including all numbers, including complex numbers, you could write something like 1/3 plus 0i. Now, me personally, I don't. That doesn't make a whole lot of sense to me, but that's how it is. Okay, now let's go ahead and do this one here. So I got, well, let's go ahead and get rid of these parentheses. So that's going to be negative 9 plus 3i. Add our real numbers together. So that would be 6 minus, because I have a negative 8 and negative 3, that would be 5i. And that's about as far as we can go. This is going to be complex. It's only complex. It's not pure imaginary, because if it was only I, then it would be imaginary. But this is complex because, well, it fits the definition. There is a real part and an imaginary part. So that is the only group that this one belongs to. Moving right along. And let's see, we're going to go ahead and multiply this. 4 times 9 is 36 plus 20i minus 9i. And I'm just using my basic FOIL. I'm just making it go in a, speed it up a bit. All right, so we've done this a couple of times, so I'm just going to kind of make it a little bit simpler. 36 plus 11i, and that would be plus 5, because we're going to reverse the sign on that one. And now it looks like we might have our final answer here. So 41 plus 11i. And this is a complex number. It is not purely imaginary because there is a real part. 41 is the real part. 11 is the imaginary part. All right, next one. We're going to have to do, with this one here, we're going to have to do that little trick where we divide and look at the remainder. So we could do it the other way, but I know this is kind of a tricky one because we didn't have a whole lot of examples with it. So I understand that, you can't really get a good feel for something when you only have one example. So I'm going to go ahead and divide it. But again, we're not looking for the quotient. We are looking for the remainder. The remainder is the important part. Again, it's like buying a big item to get the box. So 4 goes in there one time, and that would be 40 with a 1 left over. I cannot fit 4 into 1, so that's going to be 10. And that means my remainder is going to be 1. So this is equal to I to the 1 power, which is just I. And you would use that same chart that we were working with in the previous lesson here. So if you get something else, like if you get I to the 3rd, you would use this number. If you get I to the 4th, it would be 1. I squared would be negative I, and so on. All right, you would use that chart. And you can kind of derive these a little bit like we did during this lesson. But that's one way of doing it. All right, now with this one here, I'm going to go ahead and multiply. So we have a whole bunch of terms all together. So it looks like I'm going to have to square this and cube this. So that's negative 2 times negative 2 times negative 2. Negative 8. Because it's 2 negatives, cancel each other out, but then the 3rd negative is going to come back in. And that would be negative 8 to the 3rd. And square this. And square this. So I would get 49, which we can take the square root of 49. And you know what? Let me go ahead and take the square root of 49 right now, just to save a little bit of space. And that would be 7. Because again, the square and the root cancel each other out. Okay, let's go ahead and move to the next step. So multiply these out. So negative 8 times 7 would be negative 56. I to the 5th. Now, if we go back to our chart, I to the 5th would be the same as I to the 1. And again, this pattern repeats itself. For every 4 numbers of I, every 4 powers of I. So in this case here, we would just get negative 56I, and that would be only an imaginary number and a complex number. Actually, you know what? I did almost forget to include the classification for this one here. So I is the number, but it's also imaginary and it is also complex. All right, and let's go ahead and go to the last one. Multiply this out. 3 times 3 is 9. Plus, well, this is going to be a conjugate anyway, I can already tell. And I'm going to try not to take any shortcuts here. All right, and let's see, that would be 9 minus, or actually I'm going to just reverse it so it's plus 25. And that gives us a final number of 34, which 34 is just about everything again. So it's natural, it is whole, it is rational, which is Q, it is an integer, and it is a real number. And for this purpose, it is also a complex number. All right, I to the 16. All right, so let's go ahead and take 16 and divide it by 4. And that's going to be an even 4 with no remainder, right? Because we know that 16 divided by 16 divided by 4 is not going to have any remainder. 4 times 4 makes 16. So this would be I to the 0. Or actually, it'd be I to the 4. Well, I guess I to the 0 does make sense, but it's not included in this diagram here. So I to the 4 equals 1. Or actually, you know what? It does, because there is a rule with exponents, and the rule with the exponents is that every number to the 0 power is always 1. So either way you look at it, you are going to get just plain old 1. And let's go ahead and classify that. So 1 is whole. It is, oh wait, hold on. It's also natural too. So let's go ahead and start with the lowest classification. So it is natural, it is whole, it is an integer, it is rational, it is real, and it is also complex for this lesson's purpose. All right, 150, I'm going to break that down into 2 numbers that I can. I'm going to break it into 2 numbers, and I just know that this one is a square number of 25. So take the square root of 25, and you get 5 root 6. Okay, so that one was a kind of an easy one for me. And it looks like we just got to classify it. So it is irrational. So remember, if a number has a root, it is irrational. But it is also a real number, and for these purposes, it is also complex. All right, moving on to the next one. All right. Properties of complex numbers. So commutative property of complex numbers. So just, we already kind of know some of these properties, so I'm going to go ahead and just make an example. So this would be like 3 plus 4i equals the same thing, and I'm just going to reverse the term, so 4i plus 3. Right, so commutative means that the order does not matter. You can go ahead and switch them in different places. All right, and here we have associative property. And associative property means that we are going to have, let me just go make an example here. So 2 times 3 times root 4, maybe another group of, no, 5i. And this one's a pretty complicated one, just to come up with one for the associative. And this would be, 2 times 3 times 4 plus 5i. And again, we're just switching up the order, right? We're just switching up the order in this one here because we would multiply this one anyway. But the grouping is what's different. The grouping is the thing that changes. And if the grouping changes, it doesn't really change the amount of anything. And distributive should be pretty easy. Let's just come up with one that has a, where you need to distribute it. So 5 times this group is the same as if I were to just go, 5 times 6 is 30, and that would be 35i. And we've already been using that one quite a lot already today, so it's not going to be like too much of a leap. 7i times 1 is going to be 7, and that's the identity property. Identity means that it doesn't change, right? You do something, but it doesn't really change anything. The identity stays the same. And inverse means doing the opposite. So basically, if I were to have something like a complex number, so let me see, let's go with 3 minus 8i. And I would add that to the opposite. So instead of adding 3, I would add -3, and that's going to cancel it out. But I also need something that'll cancel out the 8i, so that would be positive 8i, and that would be, both of them put together would be 0. So hopefully that kind of makes sense. So if you were very good at your real number properties, this is actually not much of an extra leap. We're just including imaginary numbers as well. All right, so let's go ahead and get more of these properties. So what's going on with this one right here? Well, okay, so it might look like associative because associative has parentheses, but that's not all that's going on here. Okay, we just want to name the property. We're not working these out, but so in this case, this would be distributive property, because if we look at it, 2i times 7, right here, 2i times 7, and if I were to multiply it to the second group, that would be 2i times -5, which is, well, this one right here, so that would be distributive. And here we're going back to 1, so this would be the inverse property. And I'm just going to type in inverse. Leave that, and let's see, number 18, what's going on with this one? So it's got parentheses, but it's not multiplying. If we look at the order, -5, 4i, 9i, -5, 4i, 9i. The order is not changing, so this is not commutative. And it's not multiplication, so it's not distributive. So that must mean that it is associative property, which means, again, the group changes, but it doesn't change the meaning. All right, let's see. Add 0 to the complex number -12 plus I. So nothing happened. It's the same thing on both sides. This is identity. Oopsie. And what's happening with this one here? So we got groups, but it might look like associative, but it's not associative because check it out. The order is changed. -6 is not the first one. In fact, this is grouped here. So grouped and grouped. So it's being multiplied but the order is switched. So since the order is switched, this would be commutative. Okay, and you can probably guess what this last one is. This is the inverse because the opposite is being done. And remember, inverse means that basically, if you think about regular algebra problems, the regular ordinary algebra problems you always see, you would always do something opposite to get rid of it. So anytime you would do something opposite to get rid of it, that is inverse property. You are doing the inverse, the opposite, to get rid of it. Okay. All right, additive and multiplicative identity of 6i. So the additive. So what would I have to add to get rid of 6i? So I would have to name the additive and multiplicative identity. So I would have to add 0 to it because adding 0 does not change it. And what would I have to multiply to get it to equal the same thing? Well, timesing something by 1 does not change at all either of those things. Okay. All right, so what would I have to add to this to get rid of it? Well, okay, so I would have to get rid of the 8. So get rid of the 8 and get rid of the 3i. So that would be 8 plus 3i. And now this one's going to be a tough one because it is going to be a fraction. And if you want to multiply to get rid of a fraction, you multiply it by its reciprocal. Let's see, how can I write this in a good way? 1 over negative 8 minus 3i. So multiplying it by its reciprocal will get rid of it. You know, it's like, again, if you were trying to get rid of this term, just as an example, like this, I don't know. Oh well, anyway, almost there. All right, the set of complex number is closed under addition, so that's true. Oopsie, true. And this next one here, the set of complex number is closed under division. That is true. All complex numbers are pure and imaginary numbers, and that is false. All complex numbers are not pure imaginary numbers because if I had something like 7 plus 2i, it has a real part and an imaginary part, and it is complex. So complex, but is not pure imaginary. Let's see, a number cannot be both irrational and complex. That is false. Because, an example of that would be something like, oh gosh, I'm gonna have to write this out. So negative root 47 plus 3. And if we were to set that equal to a similar thing, right, that would be 3i or 3 plus I. Oopsie, sorry, that's 3 plus I. Times root 47. So we're not able to get them to be balanced out. So it is irrational and not complex because it would need to be 3 times I because when I take the I out, the I is going to be over here, and it's going to be I plus 3, but I just wrote it as 3 plus I because I'm trying to get it into standard form for complex numbers, and it doesn't work out. So no, it doesn't work out. And lastly, this one is going to be false. And if I have 2 times 3 plus 2i, just again, make it simple, that would be equal to 6 plus 4i. If I were to distribute it out. So the product of a real number and a complex number is a real number. So again, real number, here we have 2, and we're multiplying it to a complex number, 3i plus 2i. And if we use distributive, which is what you would do in this situation, we end up with a complex number, not a real number. So that's why this one is going to be false. And anyway, that is it for us today. So as always, I'll be around if you have any questions. But if not, then I will see you later. Okay, bye.